a WikiVidi documentaries production. Don't forget to like and subscribe. Enjoy. Industrial Revolution. The Industrial Revolution was the transition to new manufacturing processes in the period from about 1760 to sometime between 1820 and 1840. This transition included going from hand production methods to machines, new chemical manufacturing and iron production processes, the increasing use of steam power, the development of machine tools and the rise of the factory system. Textiles were the dominant industry of the Industrial Revolution in terms of employment, value of output and capital invested. The textile industry was also the first to use modern production methods. The Industrial Revolution began in Great Britain, and many of the technological innovations were British. By the mid-18th century, Britain was the world's leading commercial nation, controlling a global trading empire with colonies in North America and Africa, and with some political influence on the Indian subcontinent, through the activities of the East India Company. The development of trade and the rise of business were major causes of the Industrial Revolution. The Industrial Revolution marks a major turning point in history. Almost every aspect of daily life was influenced in some way. In particular, average income and population began to exhibit unprecedented sustained growth. Some economists say that the major impact of the Industrial Revolution was that the standard of living for the general population began to increase consistently for the first time in history, although others have said that it did not begin to meaningfully improve until the late 19th and 20th centuries. GDP per capita was broadly stable before the Industrial Revolution and the emergence of the modern capitalist economy. While the Industrial Revolution began an era of per capita economic growth in capitalist economies, economic historians are in agreement that the onset of the Industrial Revolution is the most important event in the history of humanity since the domestication of animals and plants. The precise start and end of the Industrial Revolution is still debated among historians, as is the pace of economic and social changes. Eric Hobsbawm held that the Industrial Revolution began in Britain in the 1780s and was not fully felt until the 1830s or 1840s, while T.S. Ashton held that it occurred roughly between 1760 and 1830. Rapid industrialization first began in Britain, starting with mechanized spinning in the 1780s, with high rates of growth in steam power and iron production occurring after 1800. Mechanized textile production spread from Great Britain to continental Europe and the United States in the early 19th century, with important centers of textiles, iron and coal emerging in Belgium and the United States, and later textiles in France. An economic recession occurred from the late 1830s to the early 1840s, when the adoption of the original innovations of the Industrial Revolution, such as mechanized spinning and weaving, slowed, and their markets matured. Innovations developed late in the period, such as the increasing adoption of locomotives, steamboats and steamships, hot blast iron smelting and new technologies, such as the electrical telegraph, widely introduced in the 1840s and 1850s, were not powerful enough to drive high rates of growth. Rapid economic growth began to occur after 1870, springing from a new group of innovations in what has been called the Second Industrial Revolution. These new innovations included new steel-making processes, the large-scale manufacture of machine tools, and the use of increasingly advanced machinery in steam-powered factories. Etymology. The earliest recorded use of the term, Industrial Revolution, seems to have been in a letter from the 6th of July 1799 written by French envoy Louis-Guillaume Otto, announcing that France had entered the race to industrialize. In his 1976 book Keywords, A Vocabulary of Culture and Society, Raymond Williams states in the entry for Industry, the idea of a new social order based on major industrial change was clear in Southey and Owen, between 1811 and 1818, and was implicit as early as Blake in the early 1790s and Wordsworth at the turn of the 19th century. The term Industrial Revolution applied to technological change was becoming more common by the late 1830s, as in Jérôme Adolphe Blanquois' description in 1837 of La Révolution industrielle. Friedrich Engels in The Condition of the Working Class in England in 1844 spoke of an industrial revolution, a revolution which, at the same time, changed the whole of civil society. However, although Engels wrote in the 1840s, his book was not translated into English until the late 1800s, and his expression did not enter everyday language until then. Credit for popularizing the term may be given to Arnold Toynbee, whose 1881 lectures gave a detailed account of the term. Some historians, such as John Clapham and Nicholas Crafts, have argued that the economic and social changes occurred gradually and the term revolution is a misnomer. This is still a subject of debate among some historians. Important technological developments. The commencement of the Industrial Revolution is closely linked to a small number of innovations, beginning in the second half of the 18th century. By the 1830s the following gains had been made in important technologies. British textile industry statistics. In 1750 Britain imported £2.5 million of raw cotton, most of which was spun and woven by cottage industry in Lancashire. The work was done by hand in workers' homes or occasionally in shops of master weavers. In 1787 raw cotton consumption was £22 million, most of which was cleaned, carded and spun on machines. The share of value added by the cotton textile industry in Britain was 2.6% in 1760, 17% in 1801 and 22.4% in 1831. Value added by the British woolen industry was 14.1% in 1801. Cotton factories in Britain numbered approximately 900 in 1797. In 1760 approximately one-third of cotton cloth manufactured in Britain was exported, rising to two-thirds by 1800. In 1781 cotton spun amounted to £5.1 million, which increased to £56 million by 1800. In 1800 less than 0.1% of world cotton cloth was produced on machinery invented in Britain. In 1788 there were 50,000 spindles in Britain, rising to 7 million over the next 30 years. Wages in Lancashire, a core region for cottage industry and later factory spinning and weaving, were about 6 times those in India in 1770, when overall productivity in Britain was about 3 times higher than in India. Cotton. Parts of India, China, Central America, South America and the Middle East have a long history of hand manufacturing cotton textiles, which became a major industry sometime after 1000 AD. In tropical and subtropical regions where it was grown, most was grown by small farmers alongside their food crops and was spun and woven in households, largely for domestic consumption. In the 15th century China began to require households to pay part of their taxes in cotton cloth. By the 17th century almost all Chinese wore cotton clothing. Almost everywhere cotton cloth could be used as a medium of exchange. In India a significant amount of cotton textiles were manufactured for distant markets, often produced by professional weavers. Some merchants also owned small weaving workshops. India produced a variety of cotton cloth, some of exceptionally fine quality. The early Spanish explorers found Native Americans growing a previously unknown species of good quality cotton, Gossypium hirsutum. Cotton plantations were eventually established in the West Indies and the Americas, which provided Britain with a source of this difficult-to-obtain raw material. A strain of cotton seed brought from Mexico to Natchez, Mississippi, USA in 1806 would become the parent genetic material for over 90% of world cotton production today. It produced balls that were 3 to 4 times faster to pick. Trade in textiles. The Age of Discovery was followed by a period of colonialism beginning around the 16th century. Following the discovery of a trade route to India around southern Africa by the Portuguese, the Dutch established the Verenigde Oostindische Compagnie or Dutch East India Company, and the British founded the East India Company, along with smaller companies of different nationalities which established trading posts and employed agents to engage in trade throughout the Indian Ocean region and between the Indian Ocean region and North Atlantic Europe. One of the largest segments of this trade was in cotton textiles, which were purchased in India and sold in Southeast Asia, including the Indonesian archipelago, where spices were purchased for sale to Southeast Asia and Europe. By the mid-1760s cloth was over 3/4 of the East India Company's exports. Indian textiles were in demand in North Atlantic region of Europe, where previously only wool and linen were available. However, the amount of cotton goods consumed in Western Europe was minor until the early 19th century. Pre-mechanized European textile production. By 1600 Flemish refugees began weaving cotton cloth in English towns where cottage spinning and weaving of wool and linen was well established. However, they were left alone by the guilds who did not consider cotton a threat. Earlier European attempts at cotton spinning and weaving were in 12th century Italy and 15th century southern Germany, but these industries eventually ended when the supply of cotton was cut off. The Moors in Spain grew, spun and wove cotton beginning around the 10th century. British cloth could not compete with Indian cloth, because India's labour cost was approximately 1/5 to 1/6 that of Britain's. In 1700 and 1721 the British government passed Calico Acts in order to protect the domestic woolen and linen industries from the increasing amounts of cotton fabric imported from India. The demand for heavier fabric was met by a domestic industry based around Lancashire that produced fustian, a cloth with flax warp and cotton weft. Flax was used for the warp, because wheel-spun cotton did not have sufficient strength, but the resulting blend was not as soft as 100% cotton and was more difficult to sew. On the eve of the Industrial Revolution, spinning and weaving were done in households, for domestic consumption, and as a cottage industry under the putting-out system. Occasionally the work was done in the workshop of a master weaver. Under the putting-out system, home-based workers produced under contract to merchant sellers, who often supplied the raw materials. In the off-season the women, typically farmers' wives, did the spinning and the men did the weaving. Using the spinning wheel, it took anywhere from 4 to 8 spinners to supply one hand loom weaver. Invention of textile machinery. The flying shuttle, patented in 1733 by John Kay, with a number of subsequent improvements including an important one in 1747, doubled the output of a weaver, worsening the imbalance between spinning and weaving. It became widely used around Lancashire after 1760, when John's son, Robert, invented the drop box, which facilitated changing thread colours. Lewis Paul patented the roller spinning frame and the flyer and bobbin system for drawing wool to a more even thickness. The technology was developed with the help of John Wyatt of Birmingham. Paul and Wyatt opened a mill in Birmingham which used their new rolling machine powered by a donkey. In 1743 a factory opened in Northampton, with 50 spindles on each of 5 of Paul and Wyatt's machines. This operated until about 1764. A similar mill was built by Daniel Bourne in Leominster, but this burnt down. Both Lewis Paul and Daniel Bourne patented carding machines in 1748, based on 2 sets of rollers that traveled at different speeds. It was later used in the first cotton spinning mill. Lewis' invention was later developed and improved by Richard Arkwright in his water frame and Samuel Crompton in his spinning mule. In 1764 in the village of Stanhill, Lancashire, James Hargreaves invented the spinning jenny, which he patented in 1770. It was the first practical spinning frame with multiple spindles. The jenny worked in a similar manner to the spinning wheel, by first clamping down on the fibers, then by drawing them out, followed by twisting. It was a simple, wooden-framed machine that only cost about £6 for a 40-spindle model in 1792, and was used mainly by home spinners. The jenny produced a lightly twisted yarn only suitable for weft, not warp. The spinning frame or water frame was developed by Richard Arkwright who, along with 2 partners, patented it in 1769. The design was partly based on a spinning machine built for Thomas High by clockmaker John Kay, who was hired by Arkwright. For each spindle, the water frame used a series of 4 pairs of rollers, each operating at a successively high rotating speed, to draw out the fiber, which was then twisted by the spindle. The roller spacing was slightly longer than the fiber length. Too close a spacing caused the fibers to break, while too distant a spacing caused uneven thread. The top rollers were leather covered and loading on the rollers was applied by a weight. The weights kept the twist from backing up before the rollers. The bottom rollers were wood and metal, with fluting along the length. The water frame was able to produce a hard, medium count thread suitable for warp, finally allowing 100% cotton cloth to be made in Britain. A horse powered the first factory to use the spinning frame. Arkwright and his partners used water power at a factory in Cromford, Derbyshire in 1771, giving the invention its name. Samuel Crompton's spinning mule was introduced in 1779. Mule implies hybrid, because it was a combination of the spinning jenny and the water frame, in which the spindles were placed on a carriage. which went through an operational sequence during which the rollers stopped while the carriage moved away from the drawing roller to finish drawing out the fibers as the spindles started rotating. Crompton's mule was able to produce finer thread than hand spinning and at a lower cost. Mule-spun thread was of suitable strength to be used as warp, and finally allowed Britain to produce highly competitive yarn in large quantities. Realizing that the expiration of the Arkwright patent would greatly increase the supply of spun cotton and lead to a shortage of weavers, Edmund Cartwright developed a vertical power loom which he patented in 1785. In 1776 he patented a two-man operated loom which was more conventional. Cartwright built two factories. The first burned down, and the second was sabotaged by his workers. Cartwright's loom design had several flaws, the most serious being thread breakage. Samuel Horrocks patented a fairly successful loom in 1813. Horrocks' loom was improved by Richard Roberts in 1822, and these were produced in large numbers by Roberts, Hill and Company. The demand for cotton presented an opportunity to planters in the southern United States, who thought upland cotton would be a profitable crop if a better way could be found to remove the seed. Eli Whitney responded to the challenge by inventing the inexpensive cotton gin. With a cotton gin a man could remove seed from as much upland cotton in one day as would have previously taken a woman working 2 months to process at 1 pound per day. These advances were capitalized on by entrepreneurs, of whom the best known is Richard Arkwright. He is credited with a list of inventions, but these were actually developed by such people as Thomas Hayes and John Kay. Arkwright nurtured the inventors, patented the ideas, financed the initiatives, and protected the machines. He created the cotton mill which brought the production processes together in a factory, and he developed the use of power, first horsepower and then water power, which made cotton manufacture a mechanized industry. Other inventors increased the efficiency of the individual steps of spinning so that the supply of yarn increased greatly. Before long, steam power was applied to drive textile machinery. Manchester acquired the nickname Cottonopolis during the early 19th century owing to its sprawl of textile factories. Although mechanization dramatically decreased the cost of cotton cloth, by the mid-19th century machine-woven cloth still could not equal the quality of hand-woven Indian cloth, in part due to the fineness of thread made possible by the type of cotton used in India, which allowed high thread counts. However, the high productivity of British textile manufacturing allowed coarser grades of British cloth to undersell hand-spun and woven fabric in low-wage India, eventually destroying the industry. Brought to you by WikiVidi documentaries. Would you like to know more?